Assalamu alaikum wa rahmatullahi wa barakatuh. I'm Mr. Shady Eldeeb, and today we are finding the area using integration. But first, we must remember how to integrate some function like that. fx equal 9x power 2 minus 4x minus 5. It is using this rule, fx equal x power n. So integration of fx is 1 over n plus 1 x power n plus 1. Let's apply this rule here. We have here 9x power 2, so we add 1 to 2, it will be 3, and then you divide 9 by 3, it will be like that, 9 over 3x power 3. The same thing here for negative 4x, we have power 1, so we add 1, it will be 2 here, x power 2, and then you divide 4 by 2. And then we have here x power 0, because we have here a constant 5, and x power 0, when we add 0 to 1, it will be 1, so it will be x power 1, and the 5 over 1, it will be 5. And then we adding a constant. By simplifying, 9 over 3 it will be 3, and the 4 over 2 it will be 2. And this is the final expression we got. Let's take something new. It's called definite integration. Definite integration is a normal integration but with limits. Okay, so far we have seen the integration as the opposite of differentiation, allowing us to find y equal fx when we know the gradient function y equal f dash x. In practical settings, however, the most useful use of integration is that it finds the area under a graph. Before we do this, we need to understand how to find a definite integral. Let's take an example like that. We have a curve y equal 4x power 3, and we want to find the area under this curve and between x equal 1 and x equal 5. 1 and 5 here are known as limits, which give the values of x we are finding the area between. We will write the symbol like that. This is the symbol of integration, but we will write the limits like that, from 1 to 5, 4x power 3 dx. And we integrate as normal, but put expression in square brackets like that, from 1 to 5, meaning we still need to evaluate the integrated expression using limits. How to do that? We substitute 5 instead of x here to be 5 power 4 minus 1 power 4. Look, to get the final answer, 624. So we must subtract here 5 power 4 minus 1 power 4. We got 5 power 4 by substituting 5 instead of x, and we got 1 power 4 by instead 1 by putting 1 instead of x here. Okay, and of course because it's x power 4, so it will be 5 power 4 minus 1 power 4. Don't forget that. Let's take example 1. Find the area under y equals square root x from x equal 1 to x equal 4. Look, these are the limits. By integration, square root x from 1 to 4, we know that square root x is x power half. Okay, so to integrate it, we will adding 1 to the power, it will be 3 over 2. And then the coefficient here, it will be 1 over 3 over 2. 1 over 3 over 2 is 2 over 3. The reciprocal of 3 over 2. Okay, and don't forget to put the squares like that, and here 1 and here 4. Okay, after that we are substituting 4 instead of x and 1 instead of x, and difference between them. 2 over 3 multiply 4 power 3 over 2. 4 power 3 over 2, the same of square root 4 power 3, and 4 power 3 is 64, so square root 64 is 8. okay, and 2 over 3 is here, minus, okay, minus, and we put 1 instead of x, it will be 1 power 3 over 2, which is 1, and the 2 over 3 is here, to get the final answer 14 over 3. And this is the area under y square root x, y equals square root x from x equal 1 to x equal 4. Let's take another example. Find the area of the region shaded in each of the following diagrams. Let's see diagram A. We have a curve here, y equal 4 minus x power 2, okay? We know that we must find the limits to get the area under the graph, okay? This shaded region has limits from this point to this point. This point, x equals 0 because it's y-axis. What about this point, x equal what? To get the x coordinate here, we must find the intersection point of the curve with x-axis. And to find the intersection point here, or x coordinate, we put 4 minus x power 2 equal 0, because here we know that y equals 0. Okay, to get x coordinate, we put 4 minus x power 2 equal 0. So of course x, it will be positive or negative 2. But we have here the positive part only. So x equal negative 2 is in the negative part. We need only x equal 2. Of course here x equal 2 because this is positive x. So x equal 2. Now we know that the limits from x equal 0 to x equal 2. Now everything is easy. You find the shaded region here by integration. Integrate from 0 to 2, 4 minus x power 2. Let's start. 4 is constant, so it will be 4x. And we have here x power 2. Let's add 2 plus 1 is 3, so it will be x power 3. And the coefficient here is 1, so it will be 1 over 3. And don't forget to substitute from 0 to 2. It means you substitute 2 instead of x here and x here, minus 0 instead of x here and x here. Let's start with 2. 4 times x, it means 4 times 2. 4 times 2 is 8. And here, when we put 2 power 3, it will be 8. And 8 multiply 1 over 3 is 8 over 3. Where is 0? We know that 0 multiply anything is 0. So 0 multiply 4 is 0, and 0 power 3 here is 0, and 0 multiply third is 0, and 0 minus 0 is 0, and all of this expression, 8 minus 8 over 3 minus 0, it will be 8 minus 8 over 3. Okay, so we got the final answer here, 5 and a third, and this is the area of shaded region here. Let's take diagram B. In diagram B here, this is the shaded region. Okay, and be careful. This region is not under the curve y equal 3x power 8 plus 5. But this region is the difference between two areas. Area 1 and area 2. Area 1 is the rectangle with height 8. How I know? Look at this rectangle by my mouse. This rectangle has height 8. What about base of the rectangle? What about the limits of the region? How to find the limits? Look here, this point at the intersection between y equal 8 and y equal 3x power 8 plus 5, and the same this point. So what we will do to find the point here, or to find the x coordinate here, to find the limit here and the limit here, what we'll do, we put instead of y 8, So 3x power 8 plus 5 equal 8 for finding the x coordinates. 3x power 8 equal 3 because 8 minus 5 is 3, and x power 8 it will be 1, so x it will be positive or negative 1. So this point has coordinate of x equal 1, and this one it will be x negative 1. It means that the limit here is x equal 1 and the limit here is x equal negative 1. Okay, now we know the limits. The limits is from x equal negative 1 to x equal 1. And the area of shaded region is a1 minus a2. a1 is a rectangle, this rectangle. If subtract this rectangle minus a2, which is the area under the graph, we will get this area or this region. Area 1 is 8 multiplied 2. How I know? Because I know that the height of the rectangle is 8 and the base of the rectangle is 2, because I have here 1 and I have here 1. So 2 times 8 is 16, and this is a1, all of this area. Now we must find a2 by getting the area of region under the graph, and this is by integration of the same function with using limits negative 1 and 1. So it will be like that. 8 plus 1 is 9, so it will be 3 over 9 here, and the x power 9 plus, and we have here a constant, so it will be 5x, and from negative 1 to 1 by substituting 1 instead of x here and here, minus substituting of negative 1 here and here. Let's see, it will be 3 over 9 is third, and third multiply x power 9, it will be 1 power 9, so third multiply 1 is third, and here 5 times 1 is 5, minus, and open the bracket, negative 1 here, it will be negative 1, and negative 1 multiply 3 over 9 is negative third, and negative 1 here, instead of x, it will be negative 5 at the end, and then the final answer here is 10 and 2 over 3. Note that this is the area under the graph, which is area 2. Okay, till now we didn't find the area of shaded region, which is a1 minus a2. a1 here is 16 and the a2 is 10 and 2 thirds. So the area of shaded region is 16 minus 10 and 2 thirds to get 5 and third. Now we found the area of shaded region here, 5 and third. Let's take last example. Last example we have. The diagram shows the graph of y equal 1 over root x. Show that the area of the shaded region is 3 minus 5 root 3 over 3. Look here. The shaded region here is also the difference between A1 and the A2. What is A1 and what is A2? A1 or area 1 is this trapezium. Look. And the A2 is the area under the graph. So trapezium minus area under the graph, it is the shaded region. So we must find A1 and A2. A1 is the area of trapezoid. To find the area of trapezoid, we must find base 1 and the base 2. How to find the base 1 and the base 2? By finding y coordinate here for this point and y coordinate for this point. To find y coordinate for this point, you substitute 1 instead of x here, because this point is on the graph, and the same with 3. Let's see. To find A1, you must find base 1 and base 2 of the trapezium. Look at x equal 1, y it will be 1. Why? Because square root 1 here is 1 and 1 over 1 is 1. So at x equal 1, y it will be also 1, and this is base 1. For base 2, x equal 3. So at x equal 3, y equal 1 over root 3, which is base 2. We found base 1 and base 2. We know the height of the trapezium. It will be 2 because 3 minus 1 is 2 here. Now we can find area of trapezium or trapezoid. A1, it will be base 1 plus base 2 over 2 multiply height. This is 2, and the base 1 is 1, and the base 2 is 1 over root 3. So we will write it like that, and the final answer here is 1 plus 1 over root 3. Note that this is not the final answer. It's only area 1, which is area of trapezoid. We must now find area 2. Area 2 is the area under the graph, so we must integrate the function y equal 1 over root x, like that. A2 is integrated function 1 over root x from 1 to 3 dx. 1 over root x means x power negative half, because root x is x power half, but this is in the denominator. To write it like that, it will be x power negative half. Integrate it by adding 1. Here 1 plus negative half is half. Okay, and we will write 1 over half. It will be 2 as the coefficient here. And of course from 1 to 3, by substituting, you got 2 root 3 minus 2. Because 3 power half, which is square root 3, it will be the same here with 2, so it will be 2 root 3 minus 1. Instead of x here, it will be 1 power half, which is 1, and 1 by 2 is 2, so minus 2. And this is the final answer for area 2. Okay, so area of the shaded region is area 1 minus area 2, and the area 1 was 1 plus 1 over root 3 minus area 2. This is area 2, and we will multiply negative by this coefficient and this coefficient. It will be negative 2 root 3 plus 2, and this is the final answer, which is 3 minus 5 root 3 over 3, and this is the area of the shaded region in it. Thank you very much for watching, and I hope that you will be fine all time. Thank you and goodbye.